Hi, this is Jeremy Gilbert, and today I'm going to be telling you about everything I wish I had known about soldering. It took me a long time to learn all this stuff. And I basically just want to share this because, frankly, I've never seen a YouTube video that's really explained all of this stuff as well as I understand it, and I feel like there's got to be something I need to do to get back to that. So, I'm going to first show you what soldering the right way looks like, and then we're going to actually talk about all the complex things about heat conduction and deoxidation and other things that were actually going on when I did this. So first, I'm just going to take a little bit of wire, and I'm going to strip it down. I use my little strippers. I'm very careful to make sure that I don't nick any of the wire here. This is solid core wire. I believe it's 22. I find my board, I find the pad that I want to put it into, I stick it up into the little hole, I inspect it to make sure that it's good. I'm using some blue tacky here. And then I've got my my Hacko 88, it's an FX888D, it's set to 700 degrees Fahrenheit. Use the tip. I'm going to use some of this nice brass stuff to basically clean the tip. Brass is a lot better. It doesn't subject us to the heating and cooling contraction that would an expansion that would occur with a sponge. And now I'm going to just use a little bit of my standard solder. I'm going to fill in here. And you're going to see basically what you've probably seen a lot, which is solder coming in and filling in the joint. And now I've got my nice little volcano shape, and I'm all done. Now, that is an example of everything going right, but there's actually a lot of things that can go wrong. Here's something that I started a long time ago, basically before I knew jack shit about any of this. And you can see in these connections here a lot of bad artifacts. These are the things you read about on the web that you're not supposed to do, but then the question is, how do you avoid doing them? And no one tells you that. So, like, this is basically a horrible joint. You can see the surface tension was all screwy on this on the solder ball itself. You can see some other things here, like this one. Oh, well, look at how horribly burned off all that the housing, that basically the jacket around the wire is. I mean, so there's a lot of things you can do wrong, and I think one of the things you gotta. So I think it's worth taking a step back and actually talking about what are the principles around a really good solder joint. So, you know, we start with our wire here, and we say we're gonna stick it in through our through a hole in the board, and this is my board. Now, what I want to have happen is I want a nice volcano-like fill into this joint, and the fill is actually a volcano because the surface tension of the solder in its liquid form is pulled against this wire, and ideally you want there to be a solid metal-to-metal contact between the solder and the wire, and the solder and the hole. But what actually happened in there is that a whole lot of oxidation needed to go away. So normally what happens is if I have a wire, I've got a thin layer of oxidation, which is basically atoms of the metal that have reacted and oxidized with the air. And that's actually less conductive and less mechanically strong. And so I actually need to get rid of that layer of stuff in order to have my nice bond, in my little volcano. And that's what Flux is for. So Flux is this sticky stuff that's in the middle of the soldering strand, and it's basically a core. They call it rosin sometimes. And basically, when you flowed your solder around the nice joint like I just did, what you basically have done is the flux has come out of its hole here. It's flowed around here. It's eaten away at all of the guck and the oxidation that were in all these metal joints, and it's allowed the solder to do its job. Now, just to illustrate this point, Flux also helps with heat conduction. So if I take my my soldering tip, and let me just do a quick little experiment here to show you something. If I take the soldering tip and I just stick it against the non-tinned portion, you can see it actually does not melt. The reason, again, is that there's no layer that's allowing a direct material connection between the hot soldering iron and the solder, and so I'm not actually getting any bubbling or any formation. Whereas, of course, if I do it here, I get that right away. I get nice shiny stuff right away. And now all that stuff burning off the tip, that is oxidation and slag and other things. This is what your tip is supposed to look like. And basically, what's happening here is you have to understand this thing about heat conduction that you probably learned in physics class, but you probably also forgot, like I did, which is that, if you've got two things that are going to be touching each other, heat transfers really readily. So I've got my 700 degree Fahrenheit iron, and I've got my my solder, which has a boiling point of, a melting point of, I think maybe 260 or 250 degrees Celsius. If they're touching each other, this thing is going to melt right away, right? Because the atoms here are jiggling back and forth, and they're really happy to be jiggling back and forth. And as soon as they touch the solder, the atoms here start jiggling back and forth too. But if I had any mechanical interruption here, and I didn't really have these two things touching, there's no way for the heat energy to get directly from here to here. And the only way I really have is essentially convection, which is when I heat the air, and the air moves over here, and the air then transfers the heat energy to this part, which is a lot slower. And so you really, really need the metal-to-metal contact that the flux can provide. Another thing, so always understand what the oxidation status of things are. One of the things I'll show you is if I take my tip and if I take my soldering tip and I put a blob of solder on it and let it sit for some time, what's actually going to happen is it oxidizes almost right away. And in fact, what's one of the curious things about this process is that the hotter something is, the faster it oxidizes. And so, if I let this sit for a while, what will happen is that a skin will form over the soldering tip. And over the blob of solder, and it will actually have all these impurities in it, in that skin, that are going to get in the way of making a solid connection. I don't know if I've really been letting this sit long enough for that property to happen, but let's just, by way of experiment, take a solid wire here, and I'm going to put a little bit on it, and you're going to, you see that skin? That is not wet solder flowing nicely. That's like a swimming pool with a layer of algae on it. That is not getting this piece all nice and tinned. And yet your temptation is to think, well, the solder's on there, so I'm tinning something. But that's not solder that you want anywhere in your connections, because it's basically full of all sorts of gunk. Whereas if I right away, I'm putting my tip in the brass, and I put a fresh bunch of solder on it, and you can see that burning is basically all the gunk coming away, and I repeat my experiment, you can see that the flow is so much better. Look at that, right? In fact, it wasn't even all that great because I still had the impurities on the old piece. Let's actually try that again with a completely untouched segment. Here we go. So we're now going to flow, and we're going to flow without some oxidation. We're going to see what that looks like. Let's get the focusing right here. All right. So now this is what you want it to look like, which is basically, we want none of that yucky skin. We just want a flow of liquid from one part to the other. And that's what it looks like. See how the flux in there actually helped make that all nice and smooth. And already, the more I heat it and the more that I play with the solder on here, the more I'm actually adding impurities into it, because a very, very hot bit of metal taking stuff from the air is going to get more and more and more impure. So basically the rule of this is you want to be soldering quickly. You don't want to use globs of solder that are just hanging around. You want to be adding new solder to it. Or you want to be adding more flux. So let's say that I wanted to work with a part here that I've already soldered recently, and I wanted to add something to it. One way I could do that, actually, is just add more flux. And it turns out you can buy flux just on its own. This is AMG Electronics Liquid Solder Flux. And I'll just apply some here. And you'll see what happens. I'm not going to add any new fresh flux from a soldering from a strand of solder. I'm literally just going to use my iron here, and you can see that as I manipulate this solder here, I am actually keeping it all nice and shiny. There's no skin that's getting formed. Whereas if I didn't do that, like if I switch over onto the other side and I start taking my soldering iron and adjusting connections, you'll see that what will happen is I'll rapidly run into that same gunk situation that we had before, where basically I've created that skin of oxidation that doesn't make the joint as tight. All right, so we talked about basically the fact that when you solder something well, what you're doing is you're basically all the flux that you've added into the equation is flowing in. It's eroding out the oxidation, and it's letting a much more better metal-to-metal bond. And essentially, you can either make sure that you're using flux well by soldering things right away and not letting solder blobs form, or by adding flux. It doesn't matter which. There's nothing. Solder doesn't actually ever run out. You can always rejuvenate it with flux if you want to. And so what this basically means is you need to think about oxidation states. So, like for instance, if I were to go back and want to work with this part or fix it, what I have to be thinking is, well, these parts clearly were very badly soldered, and there's a lot of oxidation and a lot of slag and other impurities in here. So if I wanted to add another joint or add another connection, I'm really going to need to think about the using flux or using fresh solder on these connections. The next thing I want to share with you is just what I've learned about stranded versus unstranded. So this is these are all stranded wires. Sorry, solid wires. These wires that we've just been using. And what's nice about solid wires is that they they can punch down into breadboards really, really well. But they're actually not very mechanically strong. And this is another thing, I guess, somewhere along the line, you learn that actually, if something's going to move a lot, like in this particular piece, if there's going to be a lot of motion like that I'd want to be concerned with in terms of the design of my project, stranded is actually far, far better. The little fibers in your stranded wire are going to be a whole lot happier moving back and forth. And the stranding actually is also nice because it doesn't conduct heat as well, and so more of the heat energy that you put into the solder into the joint is actually going to go into melting the solder as opposed to heating up the entire wire. And so let me just show you something, just by way of example. If I solder this, say I'm going to solder something to this ground pen here, and I can actually very easily, without even tinning it, I can actually, because it's a fresh joint, I can even just effectively take a little bit of solder like that, let it flow into this thing, and you can see actually that it's not flowing. Now it's flowing, and then I can take my little stranded wire, and there's enough flux in there that basically I formed a really good connection. Now what's happened there is that the flux is actually flown, it actually gets absorbed into the strands, eats away at all the oxidation, and allows the solder to fully liquefy and meld all of those strands together. And of course there's no way to see that on the microscope, but it makes for a very flexible connection. Now this thing can go back and forth, and it might eventually fall off, but we're a lot stronger than if we were using stranded. Of course, the other advantage is I use the silicone wire from Adafruit, which basically has the advantage of not being its melting temperature is really really high, and so actually you know, and you'll notice that I can't burn this soldering this silicon even with the tip of my soldering iron, whereas if I were to take you know, a regular piece of wire that didn't have silicon, you can see that basically I'm just melting it. That's all I'm doing when I touch that. So it's actually to your advantage to use the silicone stuff, and it's not very expensive. I just would use it for everything. So we've talked about how flux basically causes a joint to wetten. It removes the oxidation around the sides. It reduces the surface tension of the solder by getting rid of that skin, and it allows for a lot of flow. You know, a really strong flow. So let me just show you one other technique, and this is definitely in the advanced category. But you know, I do a lot of wiring where basically I actually stack on to other pins. So this is a teensy board, and what I've been doing here is, as I've wanted to add more and more peripherals, what I've effectively done is I've rather than creating a breakout board, I've actually just effectively been soldering right onto the edges. And this may seem like an advanced technique, and I guess it kind of is, but I want to demystify it a little bit because effectively, if you are in complete control and understanding of the oxidation states of the different things that you're working with, you can sort of control for how you get a very fine pitched wire onto a board like this. So let me just show you my technique for that. So let's say, you know, again, this is going to be a little hypothetical, but let's say that I've got a wire that represents a peripheral that I want to add onto this board. And so this wire, we'll use this wire here. And this is 30 AWG silicone coated wire. And of course, what I want to do is I want to just take the very smallest amount of stripping. Actually, that was even too much. I even want to go smaller. I want to go like this, so that basically I just have the tiny, tiny, tiny little bit. And now, what's important in this technique is you have to tin your wires. And the reason is that I'm going to have only a few seconds to really get this piece onto the terminal where I want it to live, and I want to be sure that I don't waste any time getting all the flux inside of this little tip. So typically what I do here is I'll tin it, and the tinning basically flows a bunch of solder and it's going to make a much cleaner connection when I actually go to put this somewhere. So let's say I want to add this to this pin, which is the SDA pin on the teensy. What I last soldered this teensy board, a long time ago. So what's happened is that there's all sorts of oxidation that's formed on this piece, on this pin right here, that I want to go that I'm trying to solder to, and you can see it's kind of gucky. And so the technique is basically, I don't actually need more solder. What I need is more flux. And so my technique is essentially, I go in and I add a little bit more solder to it, essentially just for the flux that's inside of it. You can see it burns off some stuff. And then relatively quickly, so that I don't burn anything else, I add my my target part there. And there we are. A nice solid connection that that I've made right into a 0.1 inch pin. Now I could even just use flux to do the same thing. So here's another example. Let's say that I want to add something to pin 0, which is over here. What I can do here is there's already all sorts of solder there. If I just add some flux, say from this jar, I don't even need to add any new solder to make a good connection. I just add a little dab. I've got a wire that's already tinned, and effectively I can just come in here and using the flux to kind of clean up the solder joint, I can effectively, hopefully there's enough solder to do this, but it should be. I can actually go in here and make a connection. I think I'm going to actually, in this particular case, I am going to need some more solder. Well, it doesn't always work, but the point is that it's not actually always the solder that you need. Sometimes, yeah. So this is a marginal joint, and this isn't a great example, but you can see that the point, which is that I was able to make the solder work just fine. What it needed was the flux in there to make the connections work better. And so, just to finish this off, I'll tidy this up by adding a little bit more solder to this joint and letting it all flow in. And there we go. And add this in like that. And now I have a nice tidy thing. Now, one of the things you'll notice is that there is a I've got a lot of flux residue from all the work that I've been doing on this board. Now, how do you get rid of that? Well, it turns out that isopropyl alcohol is is perfectly safe for electronics, and if you have the right tools, you can easily clean up all that flux residue that's on that are on the boards. So here is basically a tip. It's a conical. Looks like a Q-tip basically, and I'm feeding a little bit of very pure isopropyl alcohol onto it, and then basically I can go in and clean up all of these joints if I wanted to, and that's a nice thing to do towards the end of the project. But there's no harm in this stuff, and what's nice about the IPA is that it's basically going to effectively evaporate, so it doesn't leave itself a residue or something that you need to dry off. I mean, it's basically going to go away on its own. So anyway, these are some techniques. Basically, the rule is know when to use flux, understand what a wet connection actually looks like, and if you do that, you can make really strong, really reliable soldering in very, very tight places, and not worry about that things are going to fall apart, or that that you've got cold solder joints or things like that. And a lot of it just comes down to experience, but also just understanding some of the basics about how heat flows from one place to another, and how when you reduce the surface tension of something, you cause it to flow better. I hope it's been useful. Good luck with all your soldering.